It's so super far front because I always walk this weird. You can't see the front. I never had so many people be like, can you just
It should be alive.
It's not as much of a problem in the Netherlands. In Asia, it was all the time. It just became a habit.
Okay, so so all these things, this is the Clojure group. Some people are here since the very beginning, like Joost, I think, joined the group even before I did. So you get to know pretty much everybody.
He was on his own.
No, I think Jeff also started the group.
Yeah. All right.
So at least the both. And Hubert joined with me the third meetup or something like that. Because the three of us, me, Hubert, and Jeff at the Vapiano. That was the Clojure meetup. Anyway, so welcome everybody. This is Clojure meetup number something like 67. So we are approaching 70 consecutive months meeting for Clojure. Thank you very much for keeping up with me, I guess, and the rest of the group, and come every month here. So today we are hosted by Studyflow, as you guessed. Thank you very much for hosting us. It's great to be in where the real thing happens. So these guys are really using Clojure day in, day out in their production system, and they are going also to share with us a couple of details of what they are doing. You want to spend a few words about Studyflow?
Yeah, sure. I was on my way thinking about, because we're hiring, and I was thinking I should do this amazing talk, how amazing the atmosphere and work when I hear this. But I'm not going to do that, and instead I'm going to give the hand to David and Joost to tell you about the technology we're working with. And then if you want to work with that, then you can work at our place. No, seriously, we're looking for a really cool senior Clojure engineer to help the future of education. We have an e-learning platform which we're serving 150 schools now with. Last year was 70 schools, and we're expecting to double that next year. So if you want to work on Clojure script, event sourcing, and have a lot of impact with the stuff you're building and have fun while doing it, and speak to me or Joost or David, and I can answer any questions you have. Cool.
Thanks. So,
Okay.
floor is yours.
Yes, so I'm giving a small talk. It's going to be quite simple because I'm not the most experienced Clojure guy or general developer. This is a bit of a follow-up in the sense that Joost already a few months ago did talk a bit about event sourcing. It's not exactly a follow-up in the sense that I'm still going to introduce everything I need for this talk. So I still am going to say basic stuff about event sourcing. So just a brief outline. So I'm going to talk about the introduction, which means what we do, how we do it, some of the basics of event sourcing, and in particular, I would like to talk about our uses of read model in memory and in general the challenges and the drawbacks or everything related to that, which we recently, let's say, fixed or improved. So I want to share it with you guys. So first, I want to talk about me. I'm Davide, and I have a background in mathematics. And I started working in Clojure 1.5 years ago. Basically, the week after I joined Studyflow, we said, yeah, let's do Clojure. So I got scared. It's like, okay, but I'm really happy about it. I'm really having a lot of fun, and on the inside, it was a great move. So I'm a developer here at Studyflow, and this is me on GitHub. So if you ever want to find stuff about me. But now, yeah, let's talk about Studyflow. So we build a secondary education platform. So we are targeted for high schools. So in general, kids from the age of 12 till 18, that's more or less in the Netherlands. So that's our website. And right now we provide 2 courses. So we don't just make the platform, but we also provide the courses. So we are technically, let's say, a publisher. So we have a part of the company that actually makes the course. So instead of buying a book, they buy us, and we are a book online. And right now we serve over 100 schools. As Edo said, we have more than 50,000 students, and I looked it up numbers. In last year, we had more than 10 million questions answered correctly. So they're practicing, they're improving, they're learning their arithmetics. And here at Studyflow, we have basically a few applications. So we have a small internal Rails application that we use for entering content. As I said, a part of the company is content people, so mainly even writers. So they write really the content, the stuff. So we have the small race application, which is very basic and used only to basically copy paste all the stuff. So CRUD style, so something similar. We have Clojure web application with Ring and Hiccup that make our authentication system, so login, all the administration, so managing all the accounts, and the teacher front end, which is well, a lot of viewing and not a lot of doing, so because teachers need to see what students are doing. And then our student application are in Clojure script. So we started with OM, and then you can imagine we went to Reagent. No, but joke aside, our learning application, maybe I can show it here. So this is our layout of our application. So these are the front-facing app, in the public web. So we have these three are the Clojure web application. Learning, which is actually what students use to, let's say, learn the theory and practice on the theory. It's in OM, and that's the first application that we built. And I will say it's our core product because it's where students spend most of the time. Then we have another Clojure script application, the assessments, which we wrote much later in Reagent, also learning from the stuff that we did in learning. And that's used mainly for students, let's say, when they have to take a test, they want to take an exam, or like, teachers schedule exams that everyone takes at the same time. So that's it. And all of this, okay, we have a small session store in Redis to manage who's logging in and whatnot. Everything of this system talks to our event store, which I'm going to talk about events in a minute, but it's different color because it's a simple Postgre database where we store our events. And then out of this event store, all the application, they get back events, they get back stuff. But also we have Elasticsearch, which is connected to a Kibana application that we use mainly to do quick searching through everything that's going on. And that's used mostly for support, because when a student asks us, we can immediately see what he was doing up to that moment, and that's really good. And as I said, we have the publishing application, which the editor uses, and that's the Radar application, which publishes stuff to learning, and then also we make the tests ourselves. So we have the assessment. Talking about the server, we are currently using DigitalOcean to host our virtual machines. We have two stacks, mainly to provide rolling updates, so we don't have downtime while updating. We have only one virtual machine for the publishing because, as I said, it's internal. We have only 2 or 3 users at the same time, so it's not interesting to, if it's down, we're going to say, oh, we're going to update that, so it's okay. We have one virtual machine for each Clojure application per stack, mainly to guarantee that they're separated. So if something goes bad, not everything is done at the same time. And one decently big virtual machine for the event store, which is mainly to take our events. And we have great performance. We take a bit of memory, which I'm going to say. Yeah, just a bit.
Things like building continuous integration, not on digital.
Well, this is only the application server, but of course we have the GitLab, CI. Everything is on DigitalOcean. So I think we have.
We use some S3 for storage.
Yeah, but we also have S3, but mainly for hosting, not content, but as like storage. And then everything is on DigitalOcean. I think we have 40 virtual machines, because then we have another, basically the production layout is mirrored. So 2 stacks also for the staging. I think it's really the same. The staging machine is slightly smaller because it's only us. And then, some infrastructure. So of course, I'm omitting here like the Redis stuff, the Elasticsearch, which actually have 2 or 3 servers because we have a few events. So mainly this is the only the production, but I think in total we have 40 virtual machines. But we have that many virtual machines, which actually they do one thing at a time. So we would probably cool the downsides a bit, but it's very easy to fire up a virtual machine and just go along with it.
Somebody else's page.
Yeah, exactly. So one of the cool things we do at Studyflow, we use event sourcing, and each of our application listens, well, not really publishing, but the Clojure application, they listen to and or write domain events, which we consider to be our source of truth. And to do so, we use our own open source toolkit reel that, Joost started and well, I don't think I really have done nothing with it, but it's very complicated for me. But I think it's really great. I'm really liking, and it's really cool. As a side, if you want to do event sourcing and you want to use Rails, please get in contact with us. We can talk, we can help, we can help you figure out stuff. Talking about events, so that's the part that I'm going to introduce a bit, event sourcing. So as I said, events are our source of truth. And in general, an event records a thing that happened and, well, has a meaning in the domain. Really important is to encode the intent of the user. And of course, it's immutable, which, yeah, it's very easy and nice enclosure. Our event store is an append-only system, so, well, you can trust it because you only append stuff to it. And in general, starting from this event, you just build your application state by, processing all these events in a chronological order. And this is an example of an event. So this is the question answer correctly event. So a student practicing on a section, so by himself, not really a test, not an exam, let's say. So yeah, we have mainly the type, then this is the timestamp by UUID, and then some of the data about what and how and where. And you can see this is really what I said before, because this really records the things that happen, because no matter what, the student answered correctly, and it really encodes the intent, because the fact itself that event is here, the student wants to check about what he answered. So yeah, so in general, in that sense, we capture his intent of like, give me, tell me if I answered correctly or not. It's immutable because it's a map. And what was the other thing? Yeah, it has a meaning in the domain. So, well, we take this from domain-driven design. So all of our events really have something that, yeah, you can talk to a teacher about a question answered correctly, and they're going to understand what we're talking about, which is really nice. Right now, as I said, we have more than 50 million events, but as Edo said, we have doubled our schools. So actually, we're going to go up pretty quickly. And as I said, that's why we have 11 million, even more events per month, which probably it's only going to increase because the more features we build, the more stuff we do, the more events there are, it's only going up. So it's quite a nice and big challenge. But also, it's awesome to develop with event sourcing, because you can answer these questions, which are really meaningful for the domain people. You're really meaningful if you talk to a teacher about this, and not about other metrics that normally is measured in your application. So imagine you can go and ask a teacher, or actually give proof that the students that read again the explanation after answering incorrectly actually now get it. So your explanation is really good. So it's really interesting. And also, what kind of mistake is the most common? Or maybe we find about a question which is very difficult, and maybe we change it ourselves, and like we give the students basically a break. But if you don't have events and you have maybe now just a state, it's traditional very hard to keep track of the history of what's happened up to the final state, which basically with events you have it for free. Well, that's the reason why you do capture events. So that's a really awesome thing for the domain. For example, now we launched also some stuff about gaming, and whenever we wanted to figure out, for example, about levels, we want to make the game easy enough but not too difficult. So we asked them, how much time does student take until they will get level 10 or whatever? And you just look at the event, you count them, you play them, and it's just data. So it's really easy also to analyze stuff temporally. Oral application, as I said, they use events as source of truth, and they talk with the event store. And in general, we have that the read side and the write side of our application, they have very different needs, and that's what we use the CQRS, Command and Query Responsibility Separation, right? Mm-hmm. So basically, yeah, in general, the read side and the write side are separate. As you can see, the write side actually talks to the event store, and then, for example, commits events, and then knows what events got committed and whatnot. And the read side only listens to events and basically updates its local state. So we have that, what we call the read model, which is basically the state of an application, which we generate and or update starting from this event in a async manner. So you just listen to new event coming and you just keep track of what you need to do. Now, as a small example of this read model, because throughout the talk I'm focusing a bit on the read model, imagine our login application. So it listens simply to events about credentials. And imagine it wants to make a database because students need to log in. And this is none other than a continuous reduction on the list of events. And as you can see here, this is actual code. This really looks like a function from a reduction because, well, the first argument is the database, so the cumulative index. I'm not sure the English term, but the stuff that you keep building on. And then in this case, the second argument is this event credential added, which has the student, the email, the password. And what we do, we simply use this data to update our index. And our credential database is, well, is a map. I think everything is a map in our case.
In reality, it's an encrypted password.
Yeah, it's an encrypted password, like, but it doesn't fit too much encrypted password, so I simplified the thing. Yeah, we do encrypt stuff, huh? Yeah. And basically, this is all of the read models are done in such a way that they just have a lot of this event handler. And each application actually has only the event handler that it needs, because the way it's set up, also with real. For example, login application that doesn't care about how good you are in practicing, or the teaching application doesn't care about your password. So in that sense, each application only listens to what it cares about. And it's also really nice code-wise, because you can really distinguish and isolate the parts, and which is actually very useful for, in a second I'm gonna say why. Now I'll talk a bit about the build and the deployment, because it has to do also with the read model, because I'm talking about some DevOps. Here at Studyflow, normally we deploy commits. We use GitLab and GitLab CI, and we identify them by SHA, of course. And in general, when we commit, the test suite gets filed. If part of the, at the end of the test, there is the build process. So we build the jars, or maybe also the assets, or whatever is bundled. And we put it on S3 using that schema, so application, which can be learning, teaching, logging, all the stuff that I showed before, and the SHA. So whenever we decide to actually deploy a commit, we simply, well, we have a few scripts, we use Capistrano. Yeah, it's really straightforward. We just basically go to each server, downloads from S3 the appropriate, well, you know the application, you know the SHA, so you can get it from S3. You just start the jar, the application catches up with all previous events, builds the read model, and then from that moment on simply listens to new events oncoming. About this last step, so basically I said that you build the read model. We use an in-memory read model, which is pretty much a big map. Yeah. So it's really nice and straightforward to implement, also to navigate to, yeah, it's a piece of data which is very common to use, right? But it's not durable because it's in memory, which means what happens if the machine goes down, or what happens when you deploy, because, well, you take it down. That's basically what we do. And it's nice and easy to build a read model when you have a small amount of events, but now with 50 million, it can take 4 hours for the busiest application, which is the teaching application, which of course needs to listen to basically everything a student is doing. So this was, at the time of Jost's last talk, was basically one of the bigger challenges. I think at that time we had roughly half of those events, and it took like 2 hours. 2 hours was a lot, but manageable. You can do a few things. Now it's like 4 hours, so it's time to do something. So what about how can we, in general, well, do stuff without building the read model? How can we avoid doing that? And there are many use cases for this. Imagine you're just changing your front-end code, so the Clojure script. You make a change to the graphics, the layout, so the designer can push their own things without having to have a massive redeploy with rebuilding everything. Or in general, the system goes down. DigitalOcean a few times has gone, well, not down, but the server stops responding and you have to take it up, and it takes time. All these use cases, the read model has not changed, so you really want to keep it the way you had before. So from a from theoretical point of view, saving to disk is sounds like a good idea. So you save it to disk, you load it when you need it, and it's straightforward. But to do so, we employ a mixture of best practices and DevOps, because mainly you want to figure out when you can do it. Because, well, here I put a few use cases, but you would like the code to know itself when it needs to build it again or not. And to do that, we use this strategy. So basically, the first thing we did is to separate well enough the code that writes the read model from the code that reads the read model. Then all the codes that writes the read model, we make like a SHA-sum. SHA-sum? I don't know. Basically, then you get one SHA, which changes as soon as you change one of those files. And we say that is the read model version. Then, while the application is running, every few minutes, I'm not sure.
Like the source files?
Yeah, the source files, the source file itself. It gets periodically serialized and saved to disk. So basically, let's say a machine running at this moment has on disk saved a read model, which is at most 1 minute late.
I think it's a few minutes, right?
Few minutes, that order. But when also saves the read model on disk, also saves down the index of the last event that read model refers to. And then we basically make this assumption: if the SHA is the same, then the read model version is the same. We don't need to build anything new. And one thing that I'm not saying is that I did not write down. This thing is done per application. So you can have, like, the learning application can have a different version of the read model since previous deploy, while everything else stays the same. But of course, you are as low as the slowest part. So yeah, it's basically as if there is only one big read model version. So it's very important that when we save the read model on disk, we also save the last event that we saw, because loading it from disk is simply a shortcut from going from 0 to that index. And from that moment onwards, well, you need to listen or to process these events manually. So you need to actually kickstart this reduction that I said before. But normally these are not too many, because, well, I said we have millions in a month, and typically the downtime is not in the order of a month. And in general, during deploy, it's just a few minutes, so it's going to be done in seconds. And this brought the deploy time from hours to 5 minutes, which is actually, starting up the jar, or maybe doing some caching, some other stuff. I think loading the read model itself, even though it's a big map of 100 megabytes, so not even that big, takes 90 seconds, the slowest. Yeah. Which is, I think, a good improvement on the 4 hours. But what happens if actually we change the logic to create the read model? Now we have an old read model, and now maybe we said these events have to be handled differently. Or, well, also we add new events, and now the read model is different because it has more data. So we don't really make a distinction when we change a way that we handle old code, or we add new stuff. So it's just different, right? So you have two choices. You write a migration from the old schema or the old map to the new one, or you just rebuild it. We don't like migration, so we just rebuild it. And then, yeah, in general, as you said, you need to build it at some point once. So why not just build it with the latest version without any migration? And basically, we thought that another improvement could be done, because looking at our development process, from the commit until the time we decide to put something live to production, well, it takes some time, because, as I said, well, code review needs to be done, and then tests, which I'm not saying, well, here I put also automated, but I'm also referring, like, we'll get an iPad, we have an iPad, and we're gonna do basically manual testing and see if, even if it looks okay, because that's also a test. And then we need to have a decision. And sometimes, yeah, we wait, for example, a very important school is doing a test at the moment. Let's maybe wait until they finish, or let's wait until the students are donating, stuff like that. So, so in general, we can decide when to put it live. And normally some time happens, passes in between. a few minutes, a few hours. So why not use that time to build a read model? So the last thing we did is actually basically make a new build server, which is none other than a somewhat big virtual machine. Yeah, well, let's say it's of the size of our biggest virtual machine, which actually we deployed all the application to that, which we combine in a single jar, which is not too different to our development setup, because also, of course, in our machines we run only one thing and it has everything. And the job of this build server is just to build the read model. When it's done, compress it and upload it to S3, and then whenever you deploy or whenever you change the stack, basically it's like, well, get the stuff from S3, put it on disk, and basically the application, well, thinks that nothing has changed, so you can load it from disk. So it's a good way to use some of that time to actually well, build the read model or get ahead with the deployment. Of course, we could even, let's say, automate this on a commit per commit basis, but well, personally, I commit a lot and not everything I would like to deploy. So for now, it's still manual, because whenever, for example, whenever I make a commit, I have a clear idea. Okay, if everything goes well, this is going to go live, and only at that moment, let's say, I start the build. And yeah, for now, it's okay. But what happens when you do these kind of things, and then you discover that your read model is flawed because you have a typo in the way in the code that generates the read model, and you discover it because an angry customer calls and said, "Well, I don't see any of the progress of my student." Well, then you can say, "Well, wait 4 hours and we're going to fix it." Yeah, well, you can do that, but you want to act more quickly. And in general, depending on the nature of the change, we can using this system and the fact that we have a central repository on S3 of our read models, we could technically, you download the old float version. You maybe run a migration, which is actually a function, and then you have another map. You save it to disk and just upload it again to S3, and then you redeploy, and the server doesn't know it's actually different because you use the SHA to tell about the difference. I don't think for now we really had these kind of problems, or maybe once, only something slightly similar. But it's possible. You can do this thing, and let's say the way we build the rest of the deployment and scripts well helps. You don't have to do more ad hoc stuff than this. And in general, there are further improvements that we could do to the way we build these read models. First thing, as I said, because we actually, the read model version is the SHA sum of all the source files. Well, try to even make our source file even better, so they're more like, not atomic, but they encapsulate the information in a more separate manner. So it's less likely that you want to touch something in particular that other stuff needs to change. Let's say, so you have a lot of general, not microservices, but a lot of smaller read models, and maybe you need to change only one, and it only needs to handle a handful of events, and handling only a handful of events is faster than handling all of them. So that improves. And in general, because I think we are lucky, our domain is pretty well naturally splittable, in the sense that we could have one of our system, the full stack, one per region in the Netherlands, one per school, alphabetically ordered, it doesn't matter. Each school, actually, they don't talk to each other. So as long as all the data of one school is in one place, we're okay. Imagine if we were to split our system in just two event stores, a school from A to L and M to N, then, well, assuming they have more or less the same kind of number of students, well, you have two event store with half the size, so you basically can deploy twice as fast. And yeah, so we haven't gone to any of these directions because up to now, well, we don't really see the need because, of course, it's work to do these kind of things. And the biggest hurdle we had was this deployment time, but with the durable read model that we implemented, I think is manageable. It takes, yeah, a bit of, well, you have to be aware that maybe this is going to be live, so you need to mind and maybe schedule the build. And it's not completely automated, completely fast. But I think is working well. And well, this pretty much sums up the talk. Here are some contacts. So this is the URL for Real. As I said, if you're interested, let us know. This is the source of the previous talk, which gives a bit broader definition of event sourcing, CQRS, talks a lot about commands that I actually have not mentioned at all, talks about aggregates, so all the, not the theory, but really the stuff that's behind Real. And then this is the Studyflow email address, so if you're interested, if you'd like to work with us, send us a mail. This is me, so if you want to send me a mail, feel free to do so.
The info address actually works. I mean, you put it up there.
Yeah.
All right, sure.
No, this one doesn't go to me. I like it. I like it. This email address that goes to everyone else. No, but jokes aside, if you want to contact us, feel free. We are friendly people. This is it. Do you have any questions? General about also the way we do event sourcing. I'm having Joost here to back me, so
Sure, yeah.
if you want to, if you have any questions, yeah.
What do you use for an acceptance environment? Is your local development machines or the SIG and the stack?
For what environment?
Acceptance where you do your final testing.
We do mainly local machines. We use staging for that.
Okay. You have staging.
Yeah, we have staging. Yeah, I didn't mention it, but it's a copy of our production stack completely. So we have, even if it's a bit useless, but we have a fully small virtual machine that does only the Redis for the staging.
Okay.
And yeah, that's what we normally use.
So it is a lot less fewer events. So we basically, it's sort of a copy.
Yeah, we copy like
after a few months, and then we add some stuff to it. So
basically, the only stuff that it has, like all the accounts of the students that were there last year, and then because also the publishing, there is a version for the staging. We simply copy over the stuff that the editors do, and we publish from the staging environment to the staging applications. So it's really a copy.
Why don't you copy the whole set of events to staging?
It's very nice to
4 hours to deploy a new version.
It's very nice to the staging database is small enough that you really deploy without any of these techniques in 4 minutes. So it's really nice to do that.
Each time you touch the read model logic, you know everything will be replayed.
Mm-hmm.
So do you feel more conscious not to do some refactoring on the fly?
Well, in the sense, yes and no.
If you feel the need to add a comment and say, yeah, I will add a comment, but then it will take another
Well,
minute.
normally I have to say, most of the redeploys, they do need to build read model because we build new features and functionality and we need to touch that code anyway. So for now, it has not really been a problem because you look at what's deployable, what we're going to deploy in next version, and I built some stuff in Capistrano that tells you it's going to be slow. So maybe you say, okay, then I'm going to do it with no problem. But this technique that I said is mainly targeted when you have today we had a bug only in the front-end code. A lot of people were calling, deployed in 5 minutes. Those are the kind of the issues that you want to solve.
It makes it easier to do hot fixes, or let's say you deploy something that really took 3 hours, and then oh shit, there's this issue in there, and you can do a really quick deploy after that.
And also, this means another thing: you can revert back very quickly because we keep the old read model version on disk. I think not all of them, but let's say the last 10, the last 15. And it doesn't change really every deploy for every application. So imagine, even if it's a slow deploy, it takes 4 hours to do, then you discover a bug somewhere else, you say, okay, no, wait, I'm gonna revert. It's always fast because, yeah, okay, only really few hundreds or thousands of events needs to be played. And that's really nice. Any more questions about event sourcing, CQRS? Sure.
I have a big question. So can we have a sort of a demo of Real? Can we see how to bootstrap an application that uses Real?
Well, not really. That needs a lot of documentation and
Yeah. Well, documentation, I think it's in the plan actually
We are actually
these days.
doing a big improvement on the documentation. And we're also looking at a few things to make some of the initial design overall can be improved. So we're running into a few issues with that. So my guess is that if we do also do that, that would also make it easier to bootstrap it and to understand what is actually going on.
Okay.
So, but it is still
Next meetup,
we're
Jens?
planning.
Maybe next meetup, hopefully. Yeah, but the plan, well, the documentation is being written these days.
I was trying to save you guys from the hassle of writing the full documentation, just to show it to the people and be done with it.
Yeah.
Yeah. Also,
But, yeah,
we could make it. I
it's,
think there is no Remco made.
Remco made a start on it, and he got sort of frustrated, I guess.
Ah, very nice. I don't know that.
Yeah,
Okay.
he was complaining, so and he was right. So yeah, that's worked.
It was 1 year ago, yeah.
It works, but getting it to a state that it's actually all the parts are hooked up and running right now is not well enough documented. So it will take time. So if you're actually really interested in trying it out, give us a call because you should probably have that. Okay, you'll probably need it. So.
And I was curious, how do you perform all these tasks? Do you have some list of Jenkins jobs, or do you somebody logs in and execute some scripts?
Basically,
somebody shouts, yeah, perform.
yeah. What the automated tests in general, just closure tests. We do use make files or scripts that get automatically run by our GitLab CI. So the way it works, we have closure tests. Normal closure test, so not anything else. Upon commit, make test invokes basically line test. That's it. That's for the test for the closure part. We have, of course, a rate test for the publishing part.
When you decide to go to production, you do some sanity test and you say, okay, this.
Yeah, basically what we do, we always give like a manual testing at the end. Depends, of course, on the critical part.
Going to production, is that some scripts or something?
Pressing
a button or?
Yeah. So the way we do, you said we use Capistrano to deploy. And currently, for example, we test stuff on staging. When it's final staging, we deploy the same SHA because they are the same layout of systems. So we're confident if we deploy the same SHA on production, we don't want to have many big problems. But of course, we have bugs like that. So that happens always. But the way it currently works, we pre-deploy like one stack. When it's finished deploying and stuff, we could imagine bypass the load balancer and just connect it to the application itself. So it's the live environment that no one else is looking. You could also perform tests over there, and then only at the end you just basically you switch it over from the load balancer, and then you have the new version live.
So that basically normally you start it off. So you have half the service will be starting off with the new version. You will keep listening to the current events that are still being generated, and it sort of keeps up automatically, and you can switch it over whenever you want. And
yeah,
then it's like, so it's
then we also have also for the front end. I think it's interesting. We pass basically not with every. I'm not sure if with every request or not, but basically. The backend and the front end needs to be on the same version, and whenever we deploy, the next time the user clicks or goes anywhere, he's going to get a model so like, oh, we just deployed a new version, please reload the application, so you get new front end code. So that's also about deployment.
And for the front end, we don't really do any automated testing currently.
Yeah,
because we tried and it was horrible, and it took us much more time than actually manually.
Yeah, we're just still in general a small team, so we still do like a bit of manual testing in that. So yeah, hopefully we catch some stuff. But a few months ago, I tried also. I think it's nice to mention. I tried basically with Sauce Labs to do really integration testing in general. Yeah, so with CRJ WebDriver, so you really emulate like the end-to-end test basically. that was really, really interesting to debug, because people are much slower than scripts and robots, and in general the application sometimes, especially on their server, it's not fast enough. So it took us really a few months. And then in the end, we still had so many false negatives that we said, okay, well, it's just easier to test manually and not waste the development time.
It's a lot of, turns out it really is, if you do this really complicated single-page applications, and you do like a traditional CLDN WebDriver, click this button, wait for that to happen, then do this other thing. It's just really, you have to really write your application to actually be able to handle the test. And that's,
yeah, I do remember. I really need to put a lot of.
Well with normal units, and it will, your test will just completely break.
You're just waiting for
Yeah, I remember I need to write basically some commands that instead of course wait for a limited amount of time, is like wait until you see this model, and the model of course needs, because imagine you click and what happens in the background, there is a command, and the command gets an event, gets committed to the event store, gets back. So it's, well, it takes some time, and the robot is like, I want a new version now. So no, wait. And then all the code was simply wait until you can see everything. Wait until you can see the button. Click it. Were you able to click it? Yes or no? So
try it again if it didn't.
If it doesn't work 4 times, then please come and ask me what I need to do or whatever. It's just very annoying. Much better to have a person clicking. Yeah.
Beyond the couple of examples you mentioned, with hundreds of millions of events that you must have at this point, I would imagine the opportunity is ripe for some pretty interesting machine learning. You know, to see.
Yeah.
I mean, are you doing? I mean, anything you want to discuss that you're doing? That's
No,
pretty interesting in that area?
not at the moment. We haven't done too much of data analysis in that sense. But one of the key points actually did not really said, but one of, well, didn't say.
Maybe you will fail class within the first week. Fail already.
Yeah. Well, what's very interesting about event sourcing is that well, you can do that analysis much later, and so we just save everything, and for maybe we don't even analyze stuff right now. But if tomorrow,
it's a data scientist tree.
Yeah,
we don't have
Yeah,
data scientists.
it is. I'm just thinking, it's like that could be your whole edge. It's just the
exactly.
analysis of what.
Yeah, we only use it slightly in general. It was interesting to see how long does student take to finish everything. Or we were able to see, for example, that a lot of the students really burn through the first few questions, and they have like a short attention span, and then they forget about it, they don't care, or just need to be poked by the teacher. Or we discovered that you put a bit of gaming, like we now have a few things like.
You have to graph still?
I'm not sure, no, I don't know what is it. But we plotted a curve of how quickly people were answering questions, and it's nice, it's interesting because you can see like all of the patterns that you want. For example, well, I could show.
So we actually we wanted to develop a leveling system where students get levels out of practicing.
This is our Kibana, by the way. So this is live data.
And we wanted to see the curve of how many questions students answered correctly, so we could map our leveling system to so we could predict when they would get certain levels, and then purely out of motivational reasons, be able to set the leveling curve for them. Because at the beginning you want it to have them gain a little bit more levels, you want to get them motivated. And so we tried to map that a little bit to what they actually did out of a data set, 3 months.
This is everything in the last year stuff. So everything.
So all the events, right?
Yeah, all the events. So
that's the new
you can see the summer, New Year's. You can see all of the patterns. You can see that they practice weekly. You can see that some students practice at 2 a.m.
For some reason, yeah, we had one that actually, like a couple of weeks ago, always triggered some exception.
Yeah, I don't know, maybe someone from the States, I don't know, someone trying to break us, I don't know. But jokes aside, yeah, as Edo said, we were trying to figure out the leveling, or in general, how fast students go. And we noticed, okay, some students take 2 months to answer 200 questions. Then we looked up the outliers, Some students take 1 hour to answer 200 questions. And this is everything, all the measure you can do. So you, of course, you optimize for maybe an average student. But you need to take in mind that there are outliers, there is data analysis that you can do, there is...
So the best students like answer, they progress like 8 times as fast as the worst students through the course, which is interesting to deal with, because then you suddenly have you have these different types of students, and now we need to find a way and figure out a way how to deal with that, because how do you deal with these guys that don't do anything, and then these guys that are way super fast?
You want to keep them engaged, because you don't want to be like, this is too easy and I don't care. Or on the other end, you don't want to be too hard, and then like, oh god, Studyflow is really difficult. I'm really hard.
That's really something that you maybe want to like, really want to tune.
No, it's tuned, but you tune a bit more also.
This guy is really not going. Like he's just not really. He's not like. Relatively speaking, he's not very good at it, but he's working really hard. And today he's working really hard, so we'll give him like an extra level.
Guy for example,
can do it like in 8 times.
For the gaming, for the reward, we want to reward effort and not maybe reward like how you're naturally good at it. And so doing this kind of measurements is interesting, because then you start to asking, how can I measure it, and how can I reward the people that really try hard and they're not really good at it, and without having some people that do anything and just be over everyone.
It turned out like a brainstorming session.
Yeah, it's fine. It's fine. It's nice.
What exactly does that mean? You get harder questions?
No, it's just like
you get a number.
It's like what we figured out was, I won't go into it too long, but like we have this index of chapters and sections, right? Paragrafen. That's so. And the student finishes these chapters and get check marks. And that progress within those chapters motivates you, but it only motivates you on your actual progress and not on your effort. Well, what we want to do is we want to reward students on effort and not progress, because a really bad student that puts in more effort than a really good student that doesn't put in any effort but breezes through the content should be rewarded more. So that means suddenly you have to find a way to reward a student not on progress but on effort.
Yeah.
Then you can't use the chapter index, so you need to create a new index next to the chapter index that resembles and motivates on the effort level. So what you then do is you start, you get coins and you get level. And if you look behind you, you'll see a small fish.
Yeah, we're now developing avatars. So actually,
a student now gets a fish that grows in correspondence to how much effort he puts into learning. And our intention is that a really bad student that works all day long gets a bigger fish than a really good student that just does a little bit and breezes through it.
Is a good student receiving the same question as a bad student?
For
question started at the performance of the student.
He goes through the content. He goes through the content faster. A faster student goes through the content faster, and he gets new content faster than.
We looked it up. I looked it up. I did some research in making like an adaptive system for questions, and looking really at it. It added a lot of complexity to the system, because you have so much stuff you need to measure, because it's not just getting hard questions, but in the same chapter, in the same section, you might get questions asked not just based on difficulty, but based on different contexts, different even mathematical abilities that you need to do, and they belong, maybe let's say it's about geometry, it's about triangles, but the first you can ask how are the angles of this, and then or how are the sides, and technically speaking, which is more difficult. It's really hard to measure that, so it's really so you can figure out. I think I did at the end like a system to have also to keep consistency in these things and to be adaptive, and it sounds really complicated. And
one of your competitors is doing this with
measuring the progress.
Yeah.
Yeah, but that they actually like.
They have just one extra flag on it, like how difficult was the question and to what field does it belong.
Yeah.
And that way you
That's also something in the sense.
some mathematical thing to adjust the level, the difficulty, depending on the performance of the students.
What we are doing is something. We will probably do something not at the question level, but all the schools that we do, we serve different kind of schools, which are different goals. So we have the VMBO, so the professional schools. We have the more I'm not sure not higher education. I can PVO, yeah. So what we do is that they have different target levels, and ideally, some target levels we get to do more stuff because they're going to progress more and learn more mathematics than other stuff. So we more than per student, because we decided to maybe differentiate on the type of study what you do. Of course, it's really it's doable even to have like a manual flag, as you said, to set like this is really hard. But then at the end, we just people just take their time and go through with it, and when they're stuck, they ask the teacher.
And another thing that we do is within sections. So while you're actually practicing the material, not doing like the final test of checking if you really know the whole subject. That's already laid out. You do get the questions in a progression that is logical. So not necessarily an increasing difficulty, but logical according to our editors. To make the step points in your section, saying that maybe this is 5 steps of understanding the subject, and we do like a bunch of questions at the start.
Yeah, which might even sound not really like not related at all, but then at the end you discover that if you already studied that, you're gonna.
You get like the same kind of effect.
Yeah, exactly.
If you're going slower and you get more easy questions at the beginning, you get more questions that increase more slowly in difficulty. And if you're really quick, you just go through the steps quicker. And that way you already capture a lot of adaptability to.
Maybe I can show yet this.
Do your questions actually move up or down automatically, depending on how students choose?
Yeah, I've looked
Sure,
at
the question system maybe.
Yeah, that's right. That's what I'm saying. No,
Because it sounds like you want to find the minimum it takes to solve all the questions, right?
That's what the students want. Yes,
but not necessarily.
Educational professionals have a different opinion about it, and they will even
I have to go down.
10.1.
You need to do like 25 or 30 questions.
This is what you fixed today?
To actually really get that internalized. And even if you understand it really quickly, that doesn't mean that you're.
No, it's not this one.
Students that are going through
One of these.
They have a lot of stuff that they need to get into.
Can I look at?
their heads.
No, I
They
don't.
really have to get it.
I don't know. Let's go
And
down.
It's not really about,
No,
I get what it
I don't
does,
think
just
there's,
to really do it a lot to
set
make
up
it
No,
work.
I don't know. But
That's
ideally,
partly what we're doing also. So
Yeah, but
it's
then
not, yes.
no, I want to say like, well, now this is only one step, but ideally some sections, as you said, need to have like intermediate step, and each step is different kind of question, different. It's not, it's maybe about the same topic, but there can be different sides of it. It's really different. So that's more or less the way it is. And we figured out that going at this logical level to make them adaptive and even automatically adaptive, for now it was not really.
Yeah, I think it comes down to we actually like David wrote a 8 or 10 page document on how to apply ELO
I
rating.
wrote a nice mathematical paper with rating.
That's like the chess rating algorithm, where you rate questions against each other for difficulty based on questions answered correct and incorrect, and then you let them compete against each other. But what we figured out is that a student is already within the bounds and the context of a section within a chapter, and within that section, having an editor manually edit the order is much more efficient and accurate than having an automated system doing when something is good or not. Because what you're just going to get is questions that are incorrect are going to turn up as hard, and And there's not much variability between this, other than that the editors say,
because-
well, you need to do these questions first.
Oh, it happens. We discovered a question was very hard because I had a typo. And this was asking how much is 2 + 2, and it was expecting 5. And then it's like, of course, no one is gonna get it, but it was just a typo. And then, yeah, I need to consider. And also on the other end, we have a lot of questions, not as many like to have maybe the adaptive system, maybe have a rating, or works really well if you have a big pool of questions that you can ask. But if you have maybe 100, so then it's not enough.
You don't want to order them by difficulty, right? I mean, difficulty
No,
is
that's
like a bad
also.
right? I mean, in general, it would be better to order them by how much they relate to one another.
That's right.
So how much does this question prepare you for the next?
And the only person that can decide what that is the editor.
But isn't that also? I mean,
You can do some.
yeah, I mean, you could like the optimal order of questions would be the one with the shortest answer. You sign.
Yes, but then you're assuming that questions are heterogeneous and homogeneous questions. So like within a set of exactly the same type of question, like 7 + 3 and 6 + 4 and 2 + 8, then it makes sense to maybe order them in difficulty. But when you suddenly have 24 + 362 in there, which is a different kind of question, you always want to do the first kind of question first. And there's a certain order to the content there.
Yeah,
That is not related to difficulty, but it's just rather related to the order in which you want to learn things.
Yeah, but I mean, if you just measure how long it takes to answer each question, and you try to find an order of questions so that the time it takes to answer each of these questions is minimal, then that means that the previous questions obviously have prepared the student well for the questions that follow afterwards, right?
Yeah. And then we got into the same discussion, and then we realized, well, the editors can do it too, and it takes time.
Yeah, sure, but I mean, like the editors.
Yeah, but
the general thing, but the
data analysis can definitely can be a feedback between back and forth, but more into putting like an automated system that does stuff with it. It's a bit better. You run this analysis and then you give a report to the editors, and the editors will say, well, this makes sense, or I really think this is not.
But it makes sense to do.
Yeah, definitely.
We do some things like reports on the sections and chapters that stand out. Like, oh, this section is really difficult because like 90% of people actually don't make the test the first time they try. And some other ones are really hard.
Yeah, we do have some feedback.
That kind of stuff is automatically integrated directly into the editing system. And we do some recording on basically ad hoc reports at the moment. Basically to give the feedback to the editors when they have plans on basically change.
Do you run any experiments in the context of A/B testing?
No, not at the moment. Not. It's none. We haven't.
Not yet.
No, not yet.
It's also difficult to do checks where you have significant changes in the content will freak teachers out. So it's almost always the case that if you have a big feature, you have to send them an email first. Tomorrow you will get a big feature. Don't be afraid.
Yeah, because oh god, everything has changed. I don't know what to click. I don't know what happens.
Like we will have to set the phone meeting all the time. And so you have to be careful with just changing stuff for some people.
Yeah, and it would not be very representative if you take different schools, for example, but you also want people in the same school to do the same.
Probably, yes.
Maybe yes, school students next to each other in the class presumably should see not really the same content if they copy each other, but the same kind of stuff, right? And yeah.
So yeah, you can do things with that. You can do things based on a school, or say, do you want to?
What we I think now the next thing about the avatars, we're gonna like talk with schools and have them validate a bit of our gaming system. So we're gonna make a sneak peek in a sense. They're gonna test it on a demo account. I'm gonna set it up that's much faster to level, so as a test. And they're gonna basically what we are gonna ask is like, did you like it? Did you not like it? What you advise? So, but it's much easier to schedule sessions with school and talk with teachers. It's easy. That's it. I guess that's it. Yes.
So if you guys want to come build the future of education, you know where to go.
Okay, so I guess this concludes the agenda we have for today. For those who are new to the meetup, I think I've seen most of you at least another time. We not always have an agenda, but today we had, and it's great if people have something to share, like for instance an introduction on how to use Reel. Just saying. So if you have anything that you want to share with the community, just let me know, or even come prepared, because chances are I'm really lazy, so I really rely on you guys to come up with great ideas to share with the people.
I said it yesterday to make the presentation, and today said, well, I'm going to do it. So it works.
See, it was kind of a sponsored talk, so.
No, yeah, in the sense that
it really worked out in the past years, so I do expect that's continuing to work out in the next. That said, we are going to be again having the meetup next month. Second Wednesday of the month. I have no idea when it is. It's a meetup. You just have a look and be done with that.
The location is correct.
Sorry?
The location is correct.
Keep an eye on Meetup, because the location might change just 1 week before the event, as it happened this time around. So yeah, we usually use the Harlem office as our headquarters, but I'm really happy if we can go around. Like, I was happy to be hosted by Studyflow. If your company wants to host the Clojure meetup, I'm open for it. In any case, see you next month. I don't know if they are kicking us out. Otherwise, we can just enjoy the place. And
You guys have to leave at 2 o'clock.
Okay, I will try to be there before that. Thank you very much again, and thanks, Studyflow.
Thanks. So there's beers for anybody who wants.
Beer.
Oh yeah, there's also